this exchanger. So we will name it EX100. So that's the name of the equipment. And from the setting tab, we will open the equipment setting. From here, we will define the position of the equipment. So let's make it a vertical vessel or a vertical equipment. And from here, we will start creating the arrangement of the equipment from top to bottom. So the first element that we will define, which is that rest face, after that flange and shell. So we will start from top to bottom. So from here, we will select this, the position, the direction of set. From here, we will define the service of the equipment as flush condenser. Okay, and from here, we will define the serial number of the equipment. And the delivered blade dimensions, let's define it as 1 meter, 0.5, and 6 meters. Now let's click Save and save the information. From the app setting, we will select parallel view, parent view, and child view. Those options will give us the ability to make a rendering for elements during the creation. To figure out what's created during
Ahmed, just for a moment, can you just zoom in a bit? We are unable to see.
Rachid, can you see my screen?
We can see, but it is written in very tiny letters, so we could not be able to read it properly. So can you just?
So are you into the full screen mode at your end?
You can make full screen, Sachin.
Yeah, that I'm trying. So can you please guide me on GoToMeeting, because we are used to Teams.
I think the internet speed here is fine. So I think there is no delay from my side.
Okay,
No, there is no
just
delay. They have to make it full screen.
yeah, let me just try.
You can go to view and you can click on hide everyone.
Okay, just
On top where it is showing everyone, you can click
everyone,
that everyone
hide
and click on
yes.
hide everyone.
Yeah. Thanks, Ahmed.
Okay.
Now we can. Yeah, sure. Thank you.
Okay. After modifying the so let's say those steps again. After renaming the equipment name, we define the position, the service of the equipment, the serial number, delivered blade dimensions. After that, we update those options for making a rendering for elements during creation onto the scale. Now we will add the first element as we discussed. Here we will add the raised face and this flange. So from here we will select the design flange and add the first element, which is raised face 1. Okay, and from this list you can figure that you will find many types of elements. Let's select the linear for body flange, liner for body flange, and define the dimensions of that one, the thickness and the width. Okay, and let's click Save. Now let's add the second element, which is the body flange. So it's name it as F1 flange 1. And from here, let's select the type of this one. We will select the loose ring flat face. This type was included, but we add an option for the overall to inside if you would like to move this flange to outside or inside the connected shell. But the first type, which is the liner or body flange, this type is new based on your requirements. So from here, we will select the loose ring face. And from here, let's define the dimensions of the first flange. The inside diameter, outside diameter, the thickness, the bolt circle diameter, hole diameter, hole number, and let's make this flange as the flange, and from here we will make it overlap before on the shell with 5 millimeters. So we come back here, you can figure that this flange goes to inside of the shell with 5 millimeters, which is the thickness of the rest face. So from here we will make it the offset 5 millimeters and make the overlap to inside. Okay, now let's add the third element, which is can 1. So from here let's select can 1 and can force, and from here let's select a shell to be from plate, and from here we will define the inside diameter, thickness, longitudinal welding line orientation, the length of the course, gap of the welding, and let's save this. Now let's start creating those elements here on the scale window. That's the liner body for body flange. That's the body flange. Now you can figure that each element will be open on a separate window to show you the rendering of the element during creation. That's based on our selection. Here we will add the fourth element, which is cone. And from here, we will find centric and eccentric cone. We select the eccentric, the centric cone type, and let's define the start inner diameter. If you take a look to the image on the right hand side, you can figure that the start inner diameter and end inner diameter. And so let's define the start inner diameter. Will be 316. Thickness will be 4 millimeters. Longitudinal building line orientation. Then gap width and end thickness, and let's see. Now let's add another can, which is can 2, and from can 2 we will select the shell type, and from here we will define the dimensions: 4 millimeters, 45, 150. The gap will be 1 millimeter. Now let's create those two elements, which they are the cone and shell. Okay, now we just complete this channel. Just we need to add this flange and this linear for body flange. So let's come back to SEG, and from here let's add another body flange. So it's F2, and from here we will select the loose ring flat face, and let's define the dimensions for this one. So from here, that's the inside diameter, the flange outside diameter, flange thickness, the bolt circle diameter, bolt diameter, or the whole diameter of the bolt, number of bolts, and from here we will make it offset with 2 millimeters and select the overlap option, and from here let's add the second rest face 2. Okay, and from here let's select liner for body flange and define the dimensions of this one. So from here the inside diameter will be 3.6, thickness will be 5 millimeters and 20 millimeters. I think the thickness will be 2 millimeters. Okay. For this one, 2 millimeters. So let's save this. Okay, now let's run this model. Now we have this channel, the first channel here on those components, and now let's start creating the tube side. From here, we will select a gasket. So let's add the G1, which is the gasket between the tube sheet and this body flange. Okay, so let's add this gasket, and from here, let's select the user-defined gasket, and we will define the I inside diameter, define the thickness, and width. After that, let's add a tube sheet. So from here, let's select the tube sheet, and from here, let's select, name this one as tube sheet 1. Okay, and let's click add. From here, we will select this type. This type, our development team added based on your requirement here. This type of tube sheet with a groove from one side and flange it from the other side. So let's define the dimensions of this one. The outside diameter, the inside diameter of the left face and for the right face. Thickness of the wrist flange, okay, 2 millimeters. Thickness of the groove, thickness of the flange, and from here we will define the cut, will be 5 millimeters. Bolt circle diameter, diameter of hole for the bolt, number of holes, the next element clearance, and here on this drawing you can find that you have a clearance of 3 millimeters between the tube sheet and the shell. So that's the clearance. So you will define it here as 3 millimeters, and from here we will add a vent and define the vent angle, and let's click save. Now let's add the second can, which is connected to the tube sheet. So from here we will add can 3. Okay, and from here we will define this can and select the type of this can to be a shell from the shell type, and let's define the inside diameter, thickness, longitudinal welding diameter, the length of the shell force, and the gap. Okay, now let's add the second tube sheet. So from here, let's select tube sheet again and tube sheet 2. And from this form, let's select looks like tube sheet 1. So we will make it similar and click add. But from here, we will make it flipped to make the connection of this groove to the shell side. So let's select the flip option and click on save. Okay, now let's assemble those items on the disk inventor. Okay, that's the tube sheet. The main can of the exchanger. After that, the second tube sheet. And if we take a section view on the model to figure out the arrangement of elements, so on the assembly here, we will open the view tab, and from here, let's select a half section, and let's make a section here and take a look to the elements, so you can figure that that's the connection here, the body flange, the wrist face gasket, the first tube sheet, and here you can figure that the clearance is 3 millimeters. If we come down here, that's the second tube sheet and clearance. Okay, so let's complete the main elements of the exchanger. So here, we come down here, we can find another gasket, face and the flange, and they are looks like or similar to the other flanges. So we will not need to enter the same data area. So from here we will add a gasket as G2. And from this form, we will select, it looks like G1. Okay, so if we select it, you can figure that the same dimensions comes here. Now let's add the raised face. So from here, let's add raised face 3. And we will make it looks like raised face 2. Okay. Here, so you can figure the same dimension. After that, we will add flange 3. Flange 3. It will looks like flange 2, but we will flip the facing of this flange. So we will come back here to the flange and flip the facing. Now let's assemble those items. And let's come back to Autodesk Inventor. Here, after adding those elements, we will add the can, this can, and the ellipsoidal head right here. So after this flange, we will select bezel, and from here, let's add can 4. By the way, you can select looks like from here, so you can select looks like can 2, for example. Okay, and click save. But you need to make a refresh, so you can move to another node and come back to this node. To figure out the dimensions of this model, we will need to change the length only of this course. After that, we will add an ellipsoidal head as a bottom head. And from here, we will define the head dimension. The thickness as 4 millimeters, plate flange 25, minimum thickness after forming, and it's a flip head. Now let's click on assembly. Okay, now let's create the tube plate arrangement. But before this, let's make another section to check out the elements that we create here. That's the elements that we create. Okay, so let's remove this section and let's come back to SEG and let's select tube sheet 1. And from tube bundle, we will open this form. And from here, we will click on edit. And from this form, we will select the tube pattern. Okay, select the tube pattern reference point and where it will be referenced to the center of the bezel or offset from horizontal or vertical center. Now let's define the dimensions of the inside diameter of shell, the shell thickness 4 millimeters, the tube clearance, let's make it 0. The tube hole clearance on the tube sheet, the spacing between holes, the dimension here, the lift clearance, make it 20 millimeters, and let's make a quick draw for the tube arrangement. And from here, let's modify the select the path partitions required. Now we have it's a one path, so we will not select anything from here. We will define the rod diameter and rod hole of the shell. The same for tie rod, but we don't have a tie rod or impingement rod. Just we have a tie rod, not a sealing rod or impingement rod. From here, we will select this type of holing with a chamfer from that side. The tie rod depth is 12 millimeters. Select the size of the thread and designation of the thread. And now let's click on draw. As where your drawing here, if we take a look to this drawing, here you can figure that this arrangement at 190 degrees, so that the 0 degree, and we have 3 holes removed from this side. Here on SEG, that's the 0 degree at the top, so that at the bottom we have 180. So we have a single hole on this side, so we will remove those holes from here. So we will select the holes and remove them. And from here, let's add a tie rod to this one and another tie rod. Okay. After finishing this, we will export the information of the tube pattern arrangement and close this door. So let's come back here and add some other elements for the tube bundle elements like tube, tie rod. So from here, let's add tube. Okay, so and from the tube, we will select the first type of tube. It's standard lenses with standard lenses, but we need to define a user-defined lens. So you select this type and define the lens of the tube and click save. And from here, we will select tie rod. And from the tie rod, we will define the length of the tie rod, 5278.5. The start thread length, as mentioned here on the drawing on the right hand side, that's the thread length, and the thread offset, the end thread, the tie rod diameter, and the nut size. It will be 8 millimeters, and let's click on save. Okay, now let's add the baffles. Okay, based on this drawing right here, we have those baffles, and from here we will add baffles P1. Okay, and let's select segmental baffle like this type, and let's define the dimensions, the spacing, the thickness of the tube sheet, the clearance. After that, the location of this baffle, the orientation, and we haven't a vent. We need 4 baffles from this type. Let's add another baffle, which is P2. Let's make it looks like P1 to avoid repeating the same dimensions, but we will need to change the location only and orientation. So we will change the location of this baffle and or the cut of the orientation and the quantity of baffles. Now let's click on simply to start creating those elements. In case of deselecting the option of parent preview and child preview during creation, the elements will be created on behind on Autodesk Inventor. After that, it will be assembled, and you will see it only on the final assembly. But by using this option of child preview and parent preview, as you can figure, you can make a rendering for the element during creation and modify. That's the second baffle. Okay, now after finishing this, we will make a section on the model to figure out the arrangement of baffles. So let's make this, select this one, and here that's the baffle arrangement and the tube. Now let's start creating the pattern of elements, which is the tie rod and the tube, and make the tube sheet tooling. Okay, so we will remove this section right now and come back to SEG. And from here, let's select the tube sheet tooling. And let's start the tube sheet tooling. Those dimensions comes from our calculation, the location tools. We will need to click on start tooling, and SEG will start creating tube sheet tooling and tube and tie rod pattern. This process may take between 1 or 2 minutes to complete. It's based on the number of rows required on the model.
Ahmed, sorry to interrupt, but can we have different baffle spacing?
Yes, you can add different baffles. As we add the B1 and the B2, you can add the baffles separately and you control each baffle location. It's based on your model.
Oh, okay.
Instead of because we have 4 identical baffles, so we make a one and make a pattern with equal spacing. But if you don't have this case, you can do the each baffle separately and define the location and orientation for each one. Okay, now the pattern of tubes and rolling on tube sheet baffles. I think seconds and it will be done. Okay, now I think we finish. Okay, so if we take a section view, so let's take a section. Here let's collapse all children, and from here let's fill this habitat. So you can figure that we have the tube sheet tooling. So if we open the tube sheet, for example, you can figure that we have the tooling of on the tube sheet done by SEG, the pattern of tubes. So we have those tubes like this. Okay, and we have a single tube here. Now let's add the other attachments like nozzles and lifting lugs. So let's select the can 3, and from elements, let's add nozzle SEG. And from here, we will select the first type, which is nozzle from pipe, select the size to inches, and scalable 10S, the location, orientation, and let's keep the projection as it is right now. Let's define the name of or the service of the nozzle and click save. Now let's add a flange to this one. So from here, let's SEG flange, and from here let's select a slip on rest face flange according to as maybe 16.5. Select the size, the offset of the flange, and let's click save. Now let's come back to the SEG nozzle, and from the calculator, let's calculate the projection from the vessel center line. So from here, let's make it 340 and calculate the projection. You can figure that that's the projection of the pipe, which will be reflected here on the back view. You can see this value, which is 300. This value from this form will be reflected here when we click save. Okay. Now, if we open the set weld, we can define the fillet weld of this nozzle to the shell. You can select if you would like to make it double V or single V, but we have a small thickness, so we will use a single V. If you have a clad, you can select from those types. Now let's click on save. Let's add the second nozzle, which is S1. And from here, we will select the size to be 4 inches, 10S, the location, the orientation, and let's keep the projection as it is. the service of the nozzle is cooling water in, and from here let's add a repad. Will be like this. The thickness will be 3 millimeters, and let's click save. Now let's add a flange to this nozzle. So from here let's add S1 flange, and from here let's select the type, which is slip-on. Select the size 4 inches, and the gap, let's make it 5 millimeters. And let's come back to the nozzle to define the projection. The same projection here, 340, and let's calculate the projection of the pipe, and let's click save. Now let's define the weld detail. So from here let's define the welds. After defining S1 and S2, let's add another nozzle, which is S2. Okay, and from S2 let's make it looks like S1, but we will change the location and orientation for this nozzle. So let's refresh the view by moving to another node and come back to S2, and you can figure that all dimensions here is the same. We will define the surface to make it water out, and let's change the location for this one. Okay, and the orientation to be 90 degree, and let's click save. Now let's add a flange to this one. So from here let's add S2 flange and click save. And from here we will select this flange to be looks like S1 flange. Okay, no changes. After that we will add another nozzle, which is a vacuum pump on the second shell. Here we have this vacuum pump, which is V1. So let's add it. So from here let's select this scan and add V1. From here we will select the size, scalable, and location, orientation as 0, and let's click save. Let's add another flange, V1 flange. Okay, and from here we will make this flange looks like SEG flange because it's 2 inches. And from here we will come back and define the projection and click calculate, and let's define the fillet weld of this nozzle. After that let's add the last nozzle at the head, which is T2. So from here we will select the bottom head and add a nozzle to this head. So from here let's select the size, scalable, offset from center line, and define the service, and then say it out. That's the service of the nozzle. Let's add flange, T2 flange. It looks like V1 and SCV. Let's come back to the nozzle and define the projection. So let's define the projection to be 300, and let's calculate the projection of this one. Okay, and click save. Now let's define the finished weld, and let's create this assembly. So as you can figure, the SEG deals with the elements and create them automatically based on the database, which includes the dimensions of elements. When you select the size, for example, for flange or azimuth flange, SEG will go to the Autodesk Inventor and define the dimensions of the here I think we add a large diameter, a large width of flange. So let's come back here. Yes, it's 580. It should be 58 only. So here we have large diameter. So we will come back to SEG and make it 58 only. And the same for S2 because we make them symmetric. So 58 and click on start to modify the dimension of the reband. If you are familiar with the CAD software, you know that in CAD software you should open a new part file. After that, select a plan to make a sketch. After that, make a 3D model feature like extrude or revolve or something like that. But SEG deals with all of that automatically, make it in seconds. So you can figure how much time you will save in case of using the SEG instead of traditional ways. And all of us know drawing like this may take 2 or 3 days by AutoCAD. And I will show some mistakes in your drawings, but here in SEG drawing, you will not find any mistakes because all dimensions that you will enter, it will be reflected on the 3D model. Any change in the 3D model will be reflected on the drawing. Right? So here, after completing the equipment assembly, we will add a tailing lug and a lifting lug. After that, we will add the support clips, which is the support lug. After that, we will proceed with drawings. Here we add all nozzles. We have those nozzles here. Here we add all nozzles. If we remove the section, configure that we have this one like that. Okay, now let's add the lifting lug. So from here, let's select the CAD 3 and let's select lifting lugs and click add. And from here, let's define the dimensions of the those dimensions based on your drawing here, which is this lifting lug. Okay, so from here, let's define those dimensions: 100, 150, 12, 5, 5, 40, 40, and let's add a wear plate. From here, let's define the depth of the wear plate, width, thickness, and let's remove the fillet. So here it's automatically activates the fillet, but we will not need the fillet, so we will remove it from here and define the location of the lifting lug. Define the orientation, 45, based on this drawing here. So you can figure that the lifting lug on 45 degrees. So let's come back here and add 2 lifting lugs. We have 2 lifting lugs. And let's add tailing lug at the same type. Tailing lug. And on the tailing lug, we will make it looks like the lifting lug. So to refresh the view, we should move to another node and come back to the same node. We can figure that it's changed. We will make it only one tailing lug and change the location and orientation. So we will change the location, sorry, and change the orientation to make it perpendicular to the lifting lug. Now let's click on simply and start creating the lifting and the tailing lugs. Okay. Here, as you can figure, maybe the hole diameter is I entered the value and not correct. So we will come back here. The hole diameter is 40 millimeters. So I should come back to SEG and select the lifting lug to check this. Yes, the hole diameter I entered it as 10 millimeters. So I will modify it to 40. The same on the tailing lug. Make it 40 and click save. Before updating, let's add the anchor or tailing lug. Yes, sorry for which is the support. So let's add this. Let's add this support, and from here, let's select the first type and define the dimensions. 200. The thickness. From here. Okay, let's add a rear plate. The dimensions of the rear plate. 4, 35, 15. The location and the orientation, and we have 2 supports, and let's click save. Now, as you can figure, we make a modification on the lifting lugs, and you can figure that the color of the node changed to be on red font. That means it will need be to update it. So we have 3 colors on SEG3. The first color, which is a black color, that means this item is already done and created on Autodesk Inventor. The red color means this item may be not created, but it should need update. So the parameters of this element need to make update. And the last color, which is the third color, which is the blue color, that means this element need to be reassembled. It's created, but need to reassemble that. Now let's click on Start to update the hole diameter for lifting lug. We update it from 10 to 40 millimeters. Okay, now we done the complete 3D model of the exchanger, I think in less than 30 minutes. With all details, as you can figure, here we come back to the 3D model. Here, just adding the support clips. As you can figure, if you have the dimensions and enter it directly without taking a time to calculate or something like that, you can make it like this. We create it here in less than 30 minutes. Let's take a section at the model right here. You can figure that we done this one. Okay, with the support clips, lifting lugs, nozzles. Okay, now let's proceed with the fabrication drawings of this exchanger. Okay, before proceeding on the drawings, you should think about the drawings that you would like to create. If you would like to create a separate drawing for this channel, for example, and for the tube bundle separately and this bonnet separately, so you should make a small modification on the tree by making a grouping for elements. So let's try this here. We need to make this channel as a one assembly, not separate items here. So from this tree, we will select the first node, and from here, let's add a group. So, and name this one channel. And from here, let's select the first item, which is the face one. And the last element in this group, let's make it REST phase 2, okay, which is this one. Okay, so we will select those items to make them in one group to prepare a drawing for them. So from here, let's select F1, add the last element, and let's click Save. Now SEG will start creating an assembly, but this assembly need to update it. This update will not take seconds. Just we will click on assembly to reassemble those items on a new assembly for the group. Here, as you can figure, we talked about the elements that need to create it, and let's click simply. Sorry, I select F1, not rest phase 2. So we make those elements only on this assembly. Sorry for that. Okay, so we will need to delete this group again and define it again. As you can figure, now we have this group, the rest face with the flange, but we need to make an update. So from group, we will delete this group, sorry, and assemble them again. But in this time, we will create another group from the rest face up to the last rest face here for this channel. Okay, after finishing from here, let's be sure from the elements channel, and let's select rest face 1 and select rest face 2 here. So that's start and end. Yes, rest face 2, and click save. Now SEG will start creating a new assembly for those items. Here we need to update this by clicking on assembly. Here, after creating any grouping, just click on assembly to recreate the assembly of this group. Okay, as you can figure here, we will have a new assembly, which is the channel. Okay, this channel includes those items. Here you can figure that this channel includes this rest face, this flange, this cam, a cone, the second cam, flange, and the last rest face. Now, if we would like to create a drawing for this part only, or this assembly, we will select this group, which is a channel group, which is include those elements here. And from here, let's create a drawing. So from drawings, let's create drawing, and let's select A3, for example. And from here, let's add elevation view, and let's make a section inside the drawing. So let's keep elevation view, and then let's take a look from the back view. If I leave this as it is, and we can change it after creating the model. So let's remove this and add the bill of material. Define this channel drawing. Okay, and from here let's add division table. Okay, and let's accept this. Let's add some empty rows here. Design tab, and let's click create. Now you will figure that the scale and the location of this element, we need to modify it. I just keep the default locations and dimensions, and after creating, you can decide the scale that you need. So let's make it 6, and let's move the location here a little bit. So let's make it 10. Why make it 15 or 20? And let's click on create. So the location of this element will be like that. Now, if we take a section, for example, so let's take a section on this model like that, and we can make a projection for that one. It's based on your requirements. So we can make a detail, for example, For example, if you would like to make a detail for this element or for that one, for example, let's take a detail like that. So you can define a welding, for example, if you would like to add a weld or something like that. So let's add a weld from here. For example, like that, add some dimensions. Like that. Okay, add the dimensions of this one. Equal dimensions. Okay, define the inside diameter, for example, if you would like to make it like this. Okay, the inside diameter here. Like that, and let's add a text before it, which is 5, and copy it forward to this one. Let's add thicknesses.
Oh, Mr. Ahmed, sorry
Yes.
to interrupt. So just wanted to ask whether all these hidden lines or the tangent lines that we are seeing, can we remove those?
Or can we have a single one?
The welding
Because
lines.
yeah, normally what happens is the drawings that
Okay, so you can select them here and click like this, or you can select the suitable type from the beginning, which is the shell from without any welding lines. For example, let's select this shell type, and right here you can figure that this shell type is a shell from blade, so you can make a flat pattern. If you don't like to select this type, you can select shell without welding lines. Okay, so it looks like the pipe, so no welding lines, but it's defined by the inside diameter and thickness. Okay, so you can select this type from the beginning. So it's based on your requirements. If you need more detail, like if you would like to make a shell from different pieces and you will need to control each piece, for example, you will select this type, for example, which is shell from different pieces, so you can control each blade length. If you take a look to the image on the right hand side, this type of shell usually used in storage tanks, because in the shell course it's contains many different blades, and if you would like to modify each blade separately, so you can select this type. So it's based on your requirement. Okay, let's come back to the drawing again here. So we have the elements here, and if you would like to reflect it to the balloon, we should make a step before. For example, if you select the part only, you will find the balloon is empty here. Okay, the value of this element is not reflected. So to reflect this value, we should have a step before adding balloons to the model, which is from the assembly, we need to update item number. This step actually send the item number in SEG bill of material to each element. After finishing, I will after finishing this process, I will show you the meaning of this. SEG detect the identical elements, which is include the same name, the same material, the same weight, the same technical characteristic, and give them the same item number. For example, if we have two identical heads or two identical flanges, but with different names, but they have the same characteristics like the rating, size, and the thickness, the same material, the same weight. So all information are the same. So SEG will detect that those items are identical and give them the same item number. So to reflect this value to each element, And if you would like to add it to your drawing, sometimes or some companies don't make this column, or which is refer the item number in bill of material, but actually most companies do that. So if you would like to reflect it, you should click on update item number to reflect the item number of each element on SEG library. This process takes minutes to be reflected because I think we have many items here. Okay, so let's wait 1 more minute. I hope that you get a chance. Now we're done. So let's open the bill of material to figure out that. Here, if you take a look, we have 2 loose ring flanges with the same information, 2 liner or body flange with the same data, same material, same weights, and all of that. So SEG will accumulate the identical items and give them the same item number. Okay. So if you would like to reflect on the drawing, you should update the item. So if we come back to the drawing here by opening the drawing of the channel, so let's open the drawing of the channel. Open the simply. Here you can figure that the item number reflected here. So it's item number 9. So if we come here, item number 9 is a loose ring flange with outside diameter 510 millimeters, inside diameter, flange thickness, and the material weight of the item. Okay.
Hello, Mr. Ahmed.
Yes.
So can we change the description format in the way, let's say, because some companies may have a typical way of representing the description. So can we change that in the library
once?
Actually, we based on our reference on the naming and technical characteristics of each element, and you will find it enough. For example, if we take a look to the liner body flange, you will find the information of this element, like the inside diameter, width, and thickness. For the shell, for example, the inside diameter, thickness, and length. I think those information are enough. But regarding your question, which is how to change it, if you would like to change it, if you would like to change it, you can change it manually. Not by changing it on the library. But if you do that, you will lose the changes if you would like to update it again. That means, for example, if you change the name of this element, for example, make it like this, and click OK. Now, we change the name or the description of this element. If you have any change in this assembly again and make update to this assembly, you will lose this change. So we prefer and recommend for our customers to keep.
Okay. So we can't change it from the library.
Yeah. Yes.
We cannot change it from the library. So the associativity,
can change it from the library. Because as you know, each company has a very special bill of material and number of columns they require. But you can control the columns. If you would like to remove the material weight, for example, or material column or weight column, you can do that. I will show you. Here from the table of the bill of material, if you open the select columns, you can select the required exported columns. For example, if you would like to export the item number, quantity, and the technical characteristics. So you will select those, and if you click Save, those values will be exported to the bill of material only. So you will not have the technical characteristics or the description or material or weight. Okay, so you can control the exported data for the drawing. But the values inside, if you would like to change, it should be manual.
Okay.
I hope this point.
The thing what we have asked, because certain companies are having their certain way of representing the description, so that their shop people or the manufacturing team are actually used to of seeing these kind of descriptions. So if we suddenly change those, then there would be some resistance from their end. So that's the reason why we asked you that whether it is possible at all.
Also, Ahmed, just to add to this, can we see the description, typical description of any standard part in the bill of material, how it is showing right now?
You would like to check it?
Yeah, see the description of a standard part, not a design part, but basically a standard
Standard
part.
flange,
Let's say a standard flange or a fitting.
B 16.5 or something.
How is it represented here?
Okay, I got it. Okay, so let's, for example, here we have a nozzles on the channel. So let's
Yeah.
make simply for the channel and the check. Okay. We can check it from the bill of material. Here we have, for example, we have a seamless pipe here. So the description of the seamless pipe is NBS 2 inches, scribble like that. But you can change that if you would like to make it in DIN format, not NBS. You can do that. I will show you how you can make that. So from the setting, we will open the app setting, and from here you can, from the nozzle size, you can make it in DIN format instead of NBS. If we select save and come back to the bill of material table, if we open this one, you can figure that
Okay.
it's DIN 50.
That's good. That's good.
Okay. The same thing for nozzle. If we open the nozzle table here, you can figure that the nozzle size become here size in DIN. Okay, size in DIN, and that's the size. So you can make it like this. If we come back again and make it in DIN for an NBS format and make it save and come back to the nozzle table, you can figure that the size in NBS, and that's
Thickness of glass.
the same on the bill of material here. The
Ahmed,
size,
can you again open the nozzle table?
the nozzle table, okay. That's sorry, that's the nozzle load. So let's open the nozzle table. Yes.
Yeah. Nozzle
Okay,
schedule.
here in the nozzle table, you can find out the tag of the nozzle, which is the name that we named it on the tree, the service, the size of the nozzle, the outside diameter. You can control the exported columns on the drawing. Here's the external projection, the rebad thickness and width, the welding style, the weld fillets. You can control the supported columns. So if you would like to export the tag service size only, for example, you can select this. Okay. And here I think we enter the orientation of
the option of
we need to change this, and the V1 name. I think we need to change this. So if you would like to, so okay, we need to modify the name of the service of V1 and the orientation of the. So let's come back to V1 here, and let's select this one.
Some standard flange, how it would be represented. B 16.5.
Again, please.
PS2.
Standard flange, how it will be represented in the description.
Okay, I will show it for you. I will show
B
it.
16.5.
Here we have the orientation of the V1. It's this. Okay, and let's make it simple. We just update the nozzle service and the orientation of this nozzle, because I found them not defined it correct on the nozzle table. So let's wait to update. Okay, now it's done. So from tables, we will open the bill of material, and for flanges, if you take a look, this one it's NBS2. It's a slip-on raised face plus 100 and okay.
So sometimes that B16.5 representation would also require to be mentioned over there.
Again, please.
B16.5 or B16.47 is what we also need to mention in the description.
The standard of the flange.
Yeah, correct. So is there any provision by which we can at least change these technical characteristics without having an effect upon that associativity with the drawing?
Actually, it was there from I think a year ago, but our
Okay. So
customers asked us to remove it
sure.
because they don't like to reflect use the standard. Here they are added as a note on the general notes of the drawing. So they asked us to remove it to control it from the notes. Okay.
Ahmed,
It was there, but other customers they are yet SEG asked us to remove it, the naming or from the technical characteristics of the element.
Ahmed, one question regarding these technical characteristics.
Yes.
Uh, whatever description that we are seeing in this example for the standard flange, that is NPS2 slip-on, right? So this description would be actually retrieved from the model itself, right? The one that we are selecting in the SEG, correct?
I don't get this point. Again, please.
What I mean to say is the description that we are seeing for flange under the technical characteristics is
Yes.
getting retrieved from the model or the configuration that which we are selecting in the SCG, right?
Yes, sure. Here,
So my question is
yes,
that
it, it,
can we
it's based on the
change?
type that you selected. For
Correct,
example,
correct.
it's a slip-on raised face. Okay, so it will be appear here has a slipped-on
Yeah.
the size
So
and the slip-on. Yes.
I got you. So my next question is, can we access this library so that we can change that description in the library itself?
No, it's not possible right now. But our development team will work on a big project for making a user library, which is, I think it will be available in 6 months from now, inshallah. It will give the user to add his library. For example, if you would like to control and add another flange type, for example, you can add it and add the database for this type of flange, control the description and the technical characteristics for this flange. But right now, it's not.
Okay.
Not
So
existing.
in the future, maybe you can do like this. This is what your current representation, and
Sure.
parallel to that, what else you
But
would like to.
as you can figure, if you take a look on other software, no existing software can do all of that. We create the 3D model and the complete bill of material in less than 30 minutes. We start creating drawings. The drawing not takes minutes from you to create a drawing like this. And let's make another drawing for tube sheet, for example, to show you how we can do that. So from here, let's select this tube sheet, for example, and let's create a new drawing. And before that, let's open the tube sheet itself to take a look how we would like to look at it. So let's take a look from the left view. So let's come back here and select A3 size and select elevation view. Add two views here for the spacing of 4 millimeters. And let's take a look from the left view. Here we would like to take a look from the left view and add two views beside it. Make it okay. 18 and make the scale. Okay, let's make it 8 right now and no cube sheet on detail from 1D division. Okay, let's add division table. Right now, let's add two interviews. Let's delete this one, and let's click on create. Okay, let's change the scale or increase the scale a little bit. So let's come here, and from rows, let's drawing, and from here, let's increase the scale a little bit and move this one, increase the spacing, and click OK. Okay, now we have this detail for the flange, and if you would like to add the center line, sorry, for the wall to wall diameter like this, you can make it center line. Okay, we have this one, so we can, if you would like to modify it like this, add your dimensions here and there. Okay, the same on the other side, you can do that. So if we would like to add the whole circle diameter, the outside diameter, here if you would like to add this raised face, the outside diameter. If you would like to take a section on this, for example, if we would like to take a section on this vent hole, for example, let's take a section here, and in this section we will increase the scale of this one. Let's make it 1, 2, here to modify the dimensions. So that's the raised face. So let's make it like this. That's the whole definition. You can define the pins like that, and you can control those dimensions, by the way. Okay, so by that way you can generate a detailed drawing for a required element in minutes. And if you would like to make a general drawing, let's create a general arrangement drawing for this equipment. So from here, let's create a general arrangement drawing, and from here let's select size A1, and from views let's add an elevation view only, and from here let's select the back view and make the location of this one at 31, define the scale like this. Let's add a bill of material and the design data. Let's add nozzle table and the maximum allowable nozzle load. Let's add a client document list if you would like to modify the client document list, like mechanical data sheet, thermal data sheet. If you would like to add the documents for the client and the documents that you will submit, like mechanical calculation, all of that, let's add mechanical calculation. Here, for example, and let's add it. Okay, from the welding details, let's open the welding detail library, and you can select from this library. So let's select this and that. The cone connection, the connection of the cone for the small diameter and large diameter. The flange, we have in this type of flange, we have this type of flange. Okay, and if you would like to make it with that type, with the root of the weld, you can do it like this. Here we have a nozzle without rebag and a nozzle with rebag, which is this one. Another detail, we have this detail for the lifting lug rebag, and here this one for the lifting lug itself with the rebag. Okay, now let's go right here and general arrangement. have. Okay, and click save. Let's add another empty here. And before creating this, I would like to show you how to add the maximum allowable nozzle load. Let's save this, and from here let's select S1, and from the form of this nozzle we will select the nozzle load and define the nozzle load on this nozzle, and let's click done. And for S2, let's define the load here like that. It's just a sample. If you open the nozzle load, you can figure that you have this table for nozzle load, the force V, VC, VL, and the moments in the 3 directions. Now, if we come back to the drawing and click on drawing and click on create drawing, from here, we will start creating the drawing of the equipment. As you can figure, we have this view for the equipment. The bill of material will be generated automatically and done in the right place in the design data. The general notes. By the way, the general notes, you can import it from Excel sheet if you have those notes already written on an Excel sheet. Instead of writing it on SEG, you can import it directly. Now the all tables are done. Now we will import the welding details automatically. Okay, now we will need to change the location and the scale of the exchanger.
Ahmed?
Yes?
Can you open our drawing, which was shared for you as a reference?
Which one of those?
Yeah, this one, this
No,
one.
fabrication.
No,
GA.
the GA.
Yeah, it will baffle this.
Okay, so if you see the way the GA has been represented, so can we have it in the similar way, wherein what I was mentioning here is the lines, the way they have been shown, like as of in the inventor, what we are seeing is all the tubes and baffles and everything, like in the hidden way. So can we have it in a similar way right now what we are seeing in the AutoCAD? Can we represent it in the similar way?
Okay, if you are
Not
asking
about the dimensions,
yeah,
not about dimensions basically, but the way it has been represented, the line formatting and everything.
okay, you are talking about another software. It's not AutoCAD. It's Autodesk Inventor. Okay.
Right.
So I will show you a way to. Okay, to answer you in a good way, I would like to understand your question in a good way to give you the right answer. Okay. If you are asking for the title block and the border,
no. Let me just try to.
You asking about the tables and the arrangement of tables and fonts?
No, Emma. What I'm asking only about the elevation view where the heat exchanger has been represented.
Okay.
I'm not talking about the title block or any other part of the drawing, only the view.
You can control that easily. Here, for example, that's the nozzle table, so we can move it in any place. And if you would like to remove columns, as we discussed, if you would like to support some columns only.
Ahmed, we are discussing about the geometry, the sketch.
Yes, I know. Wait, please. Just a minute, please. Okay, I just empty a place here for this exchanger. Okay, to move it from SEG. Okay, now we need to change the location of this exchanger. So from here, we will come to the drawing, and from create drawing here, we will select model without shading lines. Okay, and let's move the Y location of this one, and let's make it like this, and let's create the drawing. Okay, here after removing all visible lines, we can control the visible lines that we or the hidden lines that we would like to review. For example, here in your drawing, you have the baffles only appear. So if we would like to make the baffles only appear, we will select the baffles from the tree and make the hidden lines appear here. So you can figure that here. So let's open the baffles simply. Okay. And let's update the assembly because when we make the grouping, the pattern is deleted. So we will just click save on the baffle here and the second baffle, and click on simply. Okay, now the baffle pattern is done. So if we come back to the drawing here, you will find the pattern of the flanges here. So we need to make this pattern visible. So from here, that's B1. Let's make it all hidden lines appear. The same for the second baffle. So you can control the visible lines or the hidden lines that you would like to make it appear on the drawing. Okay, so that's what would you like to make it appear like this one. So, and if you would like to add some dimensions on it, like from the center line here to center line there, you can make it like this, and from the first one to the last one, like that. And if you would like to add the with equal spacing, like adding a text, like we have 3 spaces, 1, 2, 3, 4, 5, 6. Like that. So you can, is that your question, to make the view like this? Did I get your point or answer your question?
So can you just zoom into the view right now? The GA.
Can what?
Just zoom into the view, the GA.
That one?
No. In Inventor itself.
Yes.
Just zoom in now.
Zoom for what? Which
Yeah.
area?
Yeah, same area. Just zoom in. Okay. So in this case, like if you want to see the hidden lines, then we'll have to enable the option to see the hidden lines, right?
Yes. Now you can control each element of the model. If you would like to visible it, for example, here, if you would like to remove those slugs from the view, you can do that from here. If we open the support lugs or telling where it is the support here. We have those supports, for example. If you would like to remove them from the view, just make them invisible.
Yes. Yes, Ahmed, I got your point because
it's up to you. You can control each element and make it visible, make it with hidden lines. All of that you can do it from there. Now let's add some let's add some details to this drawing. Let's add a top view, but from here we will make this view not aligned to be able to move it and change the scale of this top view. So let's change the scale. Let's make it like this. Okay, so we have this view right here. And now we will add some annotations for that one. So from balloon, we will select the balloon and add a balloon tag. And from here, we will select this flange and select parts only. Now we select the flange. Actually, we need to select the nozzle itself. So from here, we will select attachment and select the nozzle. After that, we will remove the back. Now let's repeat it with another nozzle, but in a slow way. So from here, we will select the balloon, and from the type here, we will select the nozzle tab. Okay. And from here, you will not be able to select the nozzle itself. So you will select the flange, for example, or any other item, and add it like this. After that, we will add a balloon and select the flange itself, like this. Okay, and remove the previous balloon. So now we have the balloon for SEG. Okay. Now let's add another balloon for the tailing lugs and the lifting lugs, like this. That's the lifting lug. That's the tailing lug. Sorry. That's the tailing lug. The support clip, like that. Okay, now we have the plan view for this. Now let's add a detail for the clip or this support. If you would like to add it on the same drawing, you can do that. How we can do that? So let's open the assembly of this one. So that's the support. So let's open the assembly of the support, and let's add a view like that from that view. So from here, let's add a detail for this clip, and let's take a look from the left view, change the scale, and let's add those views here. Okay, let's add the dimensions of the repad. You can, by the way, you can change the view name like support detail.
Ahmed?
Yes.
Okay, so my next question here is, right now what we are seeing is basically all these features are of drafting in Inventor, right? I mean, these are directly the features which you are seeing from Inventor. The way you are placing the views, modeling it, right? And also adding the balloon, right?
Yes,
so,
but the balance and all of that, it's SEG control it. If you open your drawing, standard drawing onto this inventor, you will not find the those type of the part number, part tag, item number, and bill of material. Those are controlled by SEG. SEG creates those. Okay, SEG creates those on the drawing. So, for example, if you select this on the standard template drawing of Autodesk Inventor, for example, let's open a standard drawing from Autodesk Inventor, and let's add an element here. If you open the balance, you will not find the type.
Yes, I got it.
Okay.
Yes,
and the same for tables. It will not be here. SEG controls this and send those information to Autodesk Inventor to give it the ability to create that and give you the correct values. Okay. Now, for example, if you would like to add a selectable viewer by that way, by using those features of Autodesk Inventor, we can add it like that. For example, No, it's not round, so we'll remove the round like that. So you can add the dimensions for elements and make details by that way. By the way, here you can add some standard blocks. Here, if we open the sketches, now we have the nozzle load table. So you can add the nozzle to load on shell as a block like this. Nozzle load on head as a block, that one. And select the suitable location for it in your drawing. You can add the north direction. So let's add a north direction on this one. Another shape for the north direction. And some other standard blocks. Here, for example, the name plate. So if you would like to add this one, you can add the values here. If you it's not RT2, for example, here it's not possible treatment, but I know it's a small thickness, not need a postal treatment, but I just certified one SEG Solutions manufacturing SEG year of construction, and let's click on OK to add this block, and you can control the scale of this one. So let's indicate like this, for example. You will find some standard blocks you can use it. Foundation load table for the welding details. Let's remove this. For the welding details, here we have the welding detail for the circumference welding line, longitudinal welding line. We have connection for cone to shell from the large diameter, cone to shell from the small diameter. So here we have, in this case, from the large diameter. Let's add this tangent interference lines. So from here, let's add a welding detail for. Let's add a welding detail for W3. Where is the sorry. Okay, that's welding line 3. Same for welding line 4. Okay, if you would like to add a welding line longitudinal, but we remove the welding lines here. This connection. Yes.
Hello.
Yes.
So we got it. Like most of the detailing parts we have understood. Just one request: can you go to the fabrication drawing that we have provided you?
Okay.
Can you zoom into any of the views? Okay, no issues. I guess this drawing doesn't have those details, but normally what happens, I'll just tell you a typical scenario here in India, basically. Whenever we create the AutoCAD drawings, now this one is basically in the layout form, okay? But whenever we create any AutoCAD drawings for such details, we have layers in it, right? With the different colors, different line types. I hope you are understanding what I'm trying to say here. Is basically whenever I create a GA or a detail view, all these views will be created with different layers. Okay, the layers will be for different line types. Hidden line will be in the hidden line format and with a different color. Okay, uh, so I guess you're following me right now. Is it?
Yes.
Is
Yes.
it?
Yes.
Okay. So
Here,
now,
this inventor itself, you will find this. You have a layer. For example, if you would like to remove the hidden line layer or make it invisible, If you don't like to make it exported on the printing, for example, those are the standard layers. That's the visible layer. If you would like to change the color of this layer, so let's make it green, for example. If you can change it like this, and you could import your standard line style and the thicknesses by creating your standard and export it to and import it to your drawing or your standard drawing. Okay, so the same thing here for the layers as we discussed, and the dimensions. We open the here that's the SEG standard. If you open the dimensions from here, for example, and if you open the linear dimension, you can control the text and the style of text. You can control all of this, the gap, the style of the text. You can
Okay. We got it. Just one request. Like, can you apply at least 2 to 3 layers in this particular drawing for the geometry? Basically, for the geometry, what I'm trying to say here is, let's say for the hidden line, one color or one layer. Then for the visible lines, one layer, one color. And I want to see when you export it to AutoCAD, basically. So how that associativity will stay, or will we be able to get the layers also in the AutoCAD drawing?
Yes, sure. But I want to inform you one important point. If you will go with SEG and Autodesk Inventor, we recommend for our customers don't work anymore with AutoCAD. Okay, you have a complete software, make everything. It's more powerful than AutoCAD. So why you asking for AutoCAD? I don't think no need for AutoCAD. But if you would like to do that, here let's change the color of the hidden lines. So let's select the hidden layer, and from here let's select the blue color, for example. And for the visible, let's make it green. Okay, let's select the dimensions, for example. So make it red. Okay, now as you can see, we made those changes here. Okay, and you can print directly from here instead of don't change any colors, but you will make a print on a PDF. And if you would like to export this drawing, so let's save it and come back here. From the we will select the equipment itself, and from drawings list you will find export drawing to. Okay, this option will give you the ability to export your drawing in many different extensions: AutoCAD DWG, Inventor IDW, Inventor DWG. But if you export it in Inventor DWG, you will not be able to open it in AutoCAD. Okay, so you should select AutoCAD DWG. Okay, the first selection. You can export it in PDF, DXF, DWF. So let's select AutoCAD DWG and select the location, which is on the desktop, the location of the demo of today, and GA drawing, and let's click save. Now Autodesk Inventor will save the drawing. You can figure the green bar here, which is exporting the information to the AutoCAD. Okay, now it's deleted. So let's come back to the project location and open the drawing on CAD. Now you can figure that we have the blue lines for the hidden lines, the red color, and if we open the layers, here you will find the dimensions in red color, the hidden lines in blue color, and visible in the green color. Okay, but as I said, if you will go with Autodesk Inventor and the SEG, you will not need AutoCAD. You can do anything in Autodesk Inventor. For example, if you would like to add an attachment here by making a sketch, let's do that. So you can select this and create a sketch without needing to make a 3D modeling. If you would like to go ahead with a sketch only, so So you can do that, add your dimensions directly like this. For example, just for example, if you would like, so you can, and it's by the way, it's a parametric sketch. In AutoCAD, you draw each line separately, but here, if you, for example, if you move one line, they are attached with each other. Those dimensions are already controlled. Anytime if you would like to modify, it will be changed automatically. But in AutoCAD, you should make it a parametric sketch. Automatically here will be a parametric sketch. I think you know what I mean. Hello?
Yes, yes, Ahmed, got you.
Okay, so here it's more powerful than AutoCAD. AutoCAD looks like someone draw by using a ruler and a pen. But here it's different.
No, we understand. Yeah, Ahmed. And like first of all, I would actually thank you for this all demonstration that you have given, and would also like to congratulate the about the software that you have built. Like it seems that it has been a big, very huge effort to actually make this software possible, and you have really made a very, I mean, a great software when it comes to the details that you have covered in this software. So really a very commendable job that you have done.
Alhamdulillah. I want to thank you for your valuable time, and I would like to say something before closing this session. We inform
Before
all of our customers that our development team can do elements that require the new, as per your used specs or standards from your customers. Like if you have a pipe support, for example, or some internals you would like to add, and you have a database for it, our development team will care of it, and we do that for free by now.
yes, yes, we understand, and that
For example,
that's
here, for example, when we received your drawing for the tube sheet, it was not included on this type of flange with a separate faces, not in TEMA R. So we added. It's no problem for us to create that. And we modify, by the way, we modify the type, our development team modifies the type of coupling because this question, Thousand, which is the stud outlet.
yes, Ahmed.
Fauzan,
Hello.
yes, Fauzan asked us to that a request from your side to control the dimensions of the stud outlet. Here we add this feature to give you the ability to control. Here, that's a user-defined dimension for the stud outlet. Here, that's the standard dimension. So if you select it, you can change the dimensions. And if you would like to control it, just make it user-defined dimension, and you will get the ability to change the standard dimensions of this element.
Ahmed, just one more thing about the stud itself. Can you just open it again?
Stud outlet, yes. Yeah. I deleted it. I will add it again.
inside now set diameter terminal inside diameter radius diameter तो हे standard select करता हूँ दोस्तों.
Can we change the ID in this case?
Non-standard.
Yes,
we
yes,
have
as mentioned here, that's the standard dimensions. You select the rating and the size. But if you would like to control the dimensions, here the dimensions are disabled because you don't select this checkbox. If you select it, which is user-defined dimensions, you will be able to change the standard dimensions of this one. For example, you're asking for the outside diameter. Here, that's the bore, which is inside diameter. If you take a look to the image here on the top right-hand side, the inside diameter from the bore, so you can change the bore diameter to any value. Okay, and click save to save this.
Yeah, got it.
Okay. So if you remove this checkbox, the dimensions will be as the standard dimensions.
Correct. Got it.
Yes.
Yeah, and first of all, thanks for such a quick turnaround on the request that we had put to add those features. So thanks for that as well.
Yeah,
And yeah, one more thing which we would like to see is, because since this in this heat exchanger it wasn't there, but we would like to see the spacer tube option and also the sliding strip if we can add in the heat exchanger.
Yes. Okay. Regarding to the sliding strip, here for SEG, if you would like to add ceiling bars or ceiling rod or sliding bar, just you will add a sliding bar, for example, sliding bar here on the top panel, and select the required type, and if they are parallel or they are tilted to the center line of the or a single, so you just select the type and modify the dimensions to suit your requirements.
Yes.
Regarding to the spacer, here on the SEG library, now it's not included, the spacer not included in SEG library. You will need to add it separately. Here from the accessories, you will find a spacer and a straight tube. So we will select a spacer tube. Okay, and modify the length of this one from the view. So let's open the iLogic browser. All of that inside SEG software, SEG helper. Okay, one more thing I would like to present here, which is SEG helper. Okay, if we open this app, this app will install and add some standard elements to Autodesk Inventor library. For example, here, if you have a tube like this, you can use it for the spacer. You can control the size of the tube from this form, the thickness. You can define the length. So you will make this spacer is 20 millimeters length. Let's make it 16 millimeters, 600 millimeters, like that. Define the description and the bill of material. Those values will appear. You can control the color of this one from this form. All of that generated by SEG helper, and you can use it on Autodesk Inventor standard library. Here you will find on the SEG library some standard cranes. If you would like to make a lifting study or a lifting simulation for something, you can use those cranes. Truck shackles, standard shackles, sliding support saddles for transportation, lifting top crane. One more thing regarding the simulation of the lifting simulation. We did some lifting simulations here for by using this. You can figure that we use the library which is generated by SEG and this vessel created on SEG, and make a simulation for the lifting of this equipment over a pipe rack. We make many different simulations for this equipment. It was a desalter with 5 meters diameter and 42 meters 10 to 10. We make a simulation for lifting it over the pipe rack by using 2 cranes like this. Okay, and laying it down on the truck again and move it to the lifting area like that. Okay, that's an option. If you would like to use it, you can use it. If you here to save your time, by using the library of SEG, here, which is created on inventor template, you will find some elements like bolts, jack bolt, nut, all of that. For example, in a horizontal visit, you may need to make a detail for the jack bolt for the saddle fixation. So you can do it by using this. It's not included in SEG software, but it's included on the helper, SEG helper. Okay, so for example, if you would like to generate a jack bolt, for example, like this spacer, we will open this jack bolt and open this form, modify the size, let's make it 20 millimeters, increase the length, increase the length, this length, increase that one. Okay, so the same for nut, for example, if you would like to add a nut or two nuts for this jack bolt, just select the size and modify the part number which will appear on the drawing. After that, if you would like to save all of that from SEG, we will save the document. This document, not.
Ahmed, hello.
Yes. Yes.
Just sorry to interrupt, but one more question regarding this spacer tube. So what I saw from the demonstration that you have given is we can create the separate spacer tubes, right? But how to, because what I saw from the demonstration is that is not directly into the SEG, it is in the SEG helper, right? Seems to be a separate application. So how do we take that into the heat exchanger model? Because what we saw right now is creating a single spacer tube only.
Yes, I will
But
show you.
yeah,
Okay,
there
now you are dealing with Autodesk Inventor software, so you have items or parts you would like to insert it on the general arrangement or the general assembly of the execution. So let's just save this spacer, but before that, let's take a section here to measure the required length for the spacer, the first spacer. Let's say the first spacer here. We did a part of section, so we need a spacer. Let's make these tubes invisible, and let's measure the required length. So from 2, we will measure the required length from this face up to that face. Okay, is that right? That's the required length of the spacer. So well, it's a 747.5. Okay, so we will come back to the spacer, and from here, let's modify the length. 747.5. Is that right? I think it's right. Okay. So we change the length of this spacer, and now let's save it. So we will come here and save the document. Now we will have this one, spacer 1. Okay, now we have this spacer. Now it's saved. If we come back here, we can import it. So we will select this spacer, and let's move it a little bit because you move it in the cutted area. So let's move it back. So let's remove the section. Okay, let's move it back.
So Ahmed, what basically it seems is we have to then assemble it, right, and then pattern it manually. Is it?
Yes.
Okay.
But it will not take the time, so I will show you how to do that. So from here we will make a constraint, and from here let's select this one. Now you have this spacer on the right place. Just
okay, but Ahmed, my question here is, since spacer tubes are like required in almost every heat exchangers, so why is it not the part of the SEG wherein like the way you modeled the tie rods and you included those, or the way we modeled the tube sheet and we had it by just filling up a form? So here also, is it? I mean, isn't there any feature to have that directly so that we can get all the tubes assembled as in directly there automatically?
You are right. We are working on that. Our development team working to make everything
Okay. Okay.
and make
Okay.
everything to the customer. But as you know, all softwares in the world missing some points to give the time for.
No issues, Ahmed. We totally understand. We just
Yes,
wanted to know whether it is right now the
we
part.
are working on that. Our development team working to make
Okay, good,
everything
good.
smooth and make sense. But
No
right
issue.
now, as I informed you, you can do it by using the helper, and you can add it to the assembly by that way. By the way, it will be reflected to the assembly. If we open this assembly, for example, you will find this spacer here, and you can make it visible. So the spacer is here. That's the spacer. Okay.
Okay.
But if you would like to add it to the bill of material and make it appear automatically, we need to add it to the SEG library from here. If we open the external bill of material, you can add spaces. So we will add the item number. So let's first make the arrangement by sort number. And yes, here we have 33. So we will add 34 item number. 34. Quantity, let's say 4 elements. Description, spacer. Okay, and let's open this. And from here, that's the spacer. If we open the, that's the definition of which or the technical characteristics of the element. So we will copy this here on the technical characteristics. Copy the material that we defined. Wow. Okay, we define the material here to be say 150. So we will add it here. It's 1 kilogram, for example. Part number. And that's about in spaces. Spacer 1. Okay, and save and update. Now you will get the spacer here on the bill of material. If you would like to make it appear on the drawing, you will just click on the drawing, and from here click on 3D drawing. And from tables, we will remove all those tables and just keep the bill of material and click on update tables. So in this case, SEG will update the selected tables. In this case, we select the bill of material. And so when you click on create, you will find the bill of material table will be deleted, after that recreated again, and included the, you can figure that the bill of material table will be generated again. And in this case, it will include the spacer that we add.
Okay, Ahmed, thanks for that information. So my next question is, or a request basically for you to demonstrate how to correctly open a PVLit file, because we were having some issues in opening a PVLit file. So if you can guide us through the total procedure right from the start, how to export from PVLit, or how in which export from PVLit, which format we have to export it from PVLit, and then is there any tool required to have that conversion between these two softwares, or how do we do that?
Okay. At the beginning, let's open the okay. At the beginning, for the before exporting the MDB file from BVLit, we should follow some steps and take some considerations in our mind. The first consideration, by making all names are unique. No repeated names on the model, like head, no, head 1, head 2, head 3, or flange 1, flange 2, flange 3, not repeated names. Okay. The second point, which is units. You should make the units in all length units in millimeter, not in inches. Okay. The third point, make the nozzle size in imperial. And during importing the access file, you will get this form, which actually told you what you should do. Here, that's the units, and here the how to change the size of the nozzles to be ANSI imperial instead of metric. Okay, and characters. The characters should be the used characters to create a new folder, for example. When you would like to create a new folder or a new file, you cannot add, for example, those characters. Okay, if you would like to create a new part or a new folder, Word file, or Excel file, you haven't the ability to create a name, include a character of those. For example, let's try this. If we, for example, try to create a Word file, include this character, for example. So you can get that those characters are not allowed. Okay, so the name of elements should not include a character of those, because SEG and Autodesk Inventor will create a new part. Okay, this part will take a name. This name includes a character is not correct, so you will get an error in this case during importing the file itself. So some considerations you should take care before exporting the file. Okay, now I think here regarding the repeated names, it should be not repeated. Here you can figure that we have skirt, 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 skirt. No, shell 2, cone. I think you can see this. Okay, so no repeated names. They should have unique names. The same point here. That's a file we received it from a customer and make a modification here. The name of tray 1 of 1, tray 1 of 1, tray 1 of 1. We renamed it to tray 1, tray 2, tray 3 to make them unique names. The same for rings. Something like that. Okay, so let's create a new model. So from here we will create a new project. New demo. Let's select the location and select overall. So from here, let's find so let's select this one, for example. Okay, now we have this project, and let's add this MDB file here. Now, when we select the equipment, you will find the import tab. So let's select import, and you will get this form as we discussed here. Those are the available elements on the Access database file, and those are the steps that you should make. Unique names, change the units to millimeter, define the size to be imperial, and accept that. Now we will import the file. So let's go to the desktop, and from BD demo, we will select this Access database file and click on import. Now, SEG will tell you that this equipment is a horizontal equipment. The default position for this element is horizontal. Okay, so if you would like to make it vertical, click no. If you would like to accept the information on the Access database, click yes. Now, SEG detects that we have a shell course. You can figure that this shell course was 5.8 meters, and in the standard setting of the delivered blade dimensions, we define the maximum length of the shell is 3 millimeters. In this case, SEG will calculate automatically the required number of blades on the length, the total length, not on the circumference, the total length. Okay, so from here, SEG divide this length to two shells. One of them is 3 meters and the other is 2.8 meters. If you would like to change make any change on length or welding line, you have the ability to do that. For example, let's change the length and the longitudinal welding line orientation. The same for the second one. So we will increase it and change the longitudinal welding line orientation, and click Save. Okay, now SEG detects that we have a saddle. So as you know, in BVL, it's just a saddle, not referred to a spec or something like that. But SEG will give you the ability, if you would like to make the saddle with this type of rib, or this type of rib, or this type of rib. So let's select case 1 and click on Save. Now SEG import the elements. Here we have the first element, which is the head, and the second head. But the second head, we will flip it. So let's flip it first. And now let's save the information that we received from the MDB file. How to save that? By selecting the vessel itself. After that, click on Tree Save to save all nodes on the tree. SEG in this, by clicking on this button, make some calculations and to save those information, like how much diameter of the cut on the nozzle, how much diameter of the wear plate. So some calculations done there during the saving. So this point is very important before creating the 3D. Now we save those elements. Now we will click. You can figure that it takes some seconds because this tree is small, not include a lot of elements. But in case if you have a tower, for example, you may take 2 minutes or 3 minutes to save it, because each element takes around between 2 or 3 seconds to be calculated and saved. So if you have a huge tree, it will take 2 minutes or 3 minutes. It depends on, as we discussed, it depends on the number of elements on the tree. As you can figure here, it takes seconds. Now let's start the assembly. As you can figure, we didn't select the option of preview of the elements during creation, which is making a rendering during creation. So you can figure that all elements will be created on behind. After that, assembled automatically. So if you would like to make a preview during creation, we should select those options, but we should stop the assembly before saving any information. During the assembly, don't make any save for any element. If you would like to stop, just come to the assembly and click on stop. After that, wait until this button becomes to blue. After that, you will be able to save or edit to avoid any mistakes. Now, after we will wait, just to make something on the saddle. So we will wait until the first saddle assembled. Okay, now we have the first saddle. So here, okay, now if we come back, this button becomes clear again, and you can figure that we stop at this point. So if we come to the setting and open the app, and if we select the parent preview and the child preview and click save, now if we click assembly, the preview or the rendering of elements during creation will appear again. Here you can figure that the saddle, the right saddle, simply. By the way, during the creation, you will find on our channel a lot of videos regarding to this point, which is sending for a live demos. Here you can find a live demo, which is for a tower. That's a live demo for a tower, so you can check this video for a large tower, so you can check that. Our webinar for heat exchanger, answering some questions regarding to the webinar, another tower, but a short time, advanced assembly for the second webinar. Here the some elements and some other videos or quick videos. That's a training course. Okay, it's 3 hours and a half. So you can check this video if you would like to know how to use the tools of SEG. Now let's come back to the model. Okay, now the last nozzle on the right head. Now, after importing and creating the 3D model, you can make your the fabrication requirements. Like this saddle, for example, you can modify the bottom width of the saddle, adapt it to this manway, add bolts and grip, add a nameplate, add some attachments for nozzle rips, nozzle support. All of that you can control it. For example, if we come back to the first saddle here, that one, and if we take a look, right here we need to move this base plate, so we need to minimize this spacing, okay, right here, and minimize the bottom width, change the whole offset. So let's come back here. So the first thing we will control the bottom width. So let's make it a little bit smaller than the base plate length. Okay, that's the first option. After that, first change, we will change this value. So let's check the image. Here, we need to change the whip offset. If you take a look to this image, the whip offset, so let's look for the whip offset dimension. So let's make it 20 millimeters, for example. After that, we will change the whole offset from the short edge and the long edge. So let's change this value from the long edge, the short edge, and from the long edge, let's make it 80, for example, and let's click save. Now let's click on start assembly. Now you can figure out the dimensions. Now we need to increase the spacing between reps because they are laid on the hole. So let's come back and we take a look to the side view here. We minimize this as value to be 20 millimeters instead of 50. So if we measure this value, it's 20 millimeters. So now let's increase the spacing between those reps. So let's make it 45, for example, and click save, click update. It's make a loop on all elements to update all elements if required. So you can figure that the spacing is increased. Okay, now as we discussed, you can add extra elements and all of that. Okay. Any questions regarding to the DDL point?
No, so far clear, but what we would like to show here is we would like to share our screen and show you basically how we are following that procedure and the error that we are getting. So is it okay?
Okay.
All right, so we'll share our screen. Just a minute. Okay, so can you allow us to share the screen?
I will stop sharing my screen.
Okay, let me try.
I think
you need to make us the host or maybe the presenter. There could be
the
some
one who has
option.
Rachid, would you mind to give the access?
Yes, I'm giving.
Okay.
Which machine? Deepak or Sachin? Which machine I need to give the access?
Yeah, make Sachin the host
Host name.
or the presenter, whatever it is.
Yes, you are now. Yes, you are now presenter. You can share your screen.
Thank you. We'll just start in a moment.
Okay. So
So
cancel.
I hope it is visible now.
Yes, it is visible.
Okay. So Mr. Ahmed, we are just following the procedure to open the PVLead file.
Would you
And
mind to open the Access database file separately? I would like to check the Access database.
Access file.
Would you mind to open it?
Just a
Touch
minute.
it. Okay. Before importing it, please. Before importing.
Uh,
Okay. Touch it. Can you hear me, please? Touch it.
yes, we are hearing.
1 minute. 1 minute before importing. Would you mind to wait, please? Would you mind to open the Access database file before importing anything?
You mean to say the MDB file or?
Yes, the Access database file, the MDB file itself. I would like to check it separately. To know if it's in a correct way or not.
So which file you mean to say?
Anyone who has a file that you would like to import.
Okay. Right click any but it has to be opened in Microsoft database, right? Access.
Yes.
The database check.
Well, I think something missed on this one.
Is it okay if we share that file with you?
Yes, sure. Send it to me.
Part of it. Can we share this through the GoToWebinar or we'll have to email you?
I don't know. We should ask.
Sachin.
Ratchet, can we share some files here?
I think email should be fine. Email.
So whom should I email this to? Hello?
You can mark to Ahmed and Fozan.
Okay. So Mr. Ahmed, can you put your email ID in the chat box?
Okay. Sorry.
So Mr. Ahmed, we have just emailed that file to you. If you can open.
Okay, so let's open this access database file, and let's check the elements. Here we have a lower skirt, upper skirt. Yes, that's the first point. Here we have two skirts on the bottom head. But in SEG software, that's one point. We should have one skirt only. And on the skirt itself, we will define if we have two shell blades or three or four. We have up to 4 blades. So in this case, we will modify this one to make it as a one skirt only and accumulate the two lenses here. So the total length of the skirt should be 184 plus 600. So that's the total length of the skirt. Okay, so let's delete this one, delete this record, and keep one skirt only. And we will change the total length here, 184. Okay, now let's check the nozzles, the name of nozzles. Here we have the, yes, here you can figure that I told you that the nominal diameter of nozzles should be in ANSI imperial, not in them. So for example, this nozzle should be 4, 4, 2, 2, 4. If you select those options from BVLit itself, you will not need to modify it on Axis. But let's modify it right now by hand. Okay, 24, 6 inches, 4 inches, 3 inches, 1 inch, 6 inches, 2 inches. Okay, so we modify the nominal diameter of the nozzle. Okay, and any other data?
Mr. Ahmed?
Yes.
What if we have any SRN nozzles there?
Self-reinforcing nozzles
Where how do
the
we
actual
put the
dimensions
size?
needs to be provided, right?
Okay. Actually, in the Access database file, no information regarding the self-reinforcement. And in the BVLit itself, you will define it as the base thickness. You will make it differ from the shell thickness or the head thickness. So no way to make it highlight on this and say that it's self-reinforcement.
No.
But in SEG, you can do that. How I will tell you after importing this one. I will tell you how you can modify a nozzle or make a nozzle as a self-reinforcer.
No, Ahmed, question here was like, let's say if there is any SRN nozzle and we are also trying to open that from PVLit file. Okay, so in that case, we'll have to change the unit for that also.
The inches, nozzle size.
I don't get this point. When you make the nozzles as ANSI imperial, all sizes will be exported in ANSI imperial. So all nozzle sizes, if we take a look to the nozzles again, all sizes here will be in inches or in
Okay.
Okay. So now we will save this as it is right now. Now I think we saved it. So here we can import it. So from drawing, we will import. So we will select the Access database file. And from here, we will select here our demo DB2. So we will select this Access database file from your side. Now it's a vertical visit. So let's click save because it's a vertical. Let's minimize those. Now we have a course, the length is 2 meters, 0.5. Let's accept the orientation. If you would like to modify the orientation, you can do it during importing. So let's make this and save. Now we have another one. So we could modify the longitudinal building line orientation like this. Click save. Now we have those heads. Okay. Now we have the first head here as a flipped head. Now we will select the shell itself as we mentioned. After that, now you can figure that no errors during import. Okay? Hello?
Yes, yes, we are with you.
Now, during import, after modifying this, so I mentioned on the beginning, there are some steps you should follow to export the access database file in a correct way. Now, when we select for example, if we select the skirt here, as mentioned, we have two skirts, two courses. Okay, so we will add another skirt course here and make the length of this skirt as 600 millimeters. Okay, and that's the total length. And let's check the thickness here is 16 millimeters. Thickness here 5. So we will make the thickness here 5 millimeters and let it accept this. Now, before that, we will select the equipment and click on 3 save. Okay, now SEG will make some calculations. Excuse me, 10 seconds. I will drink some water and come back. Okay, as mentioned, the saving time depends on the number of nodes on the tree. Each node takes between 2 and 3 seconds to save or for saving. So this tree may take 1 minute and a half around that. Now it's saved. Now we can run the assembly. Now if we click on start assembly, the assembly will start creating. Before that, let's stop the assembly and change the setting to make it preview child and parent to make a preview for elements during creation. By the way, for the elbows, which is connected to nozzles, no information about it on the access database file. Okay, and we talked many times to Hexagon BBM to solve those issues on the access database file to make it include more information. And they promised us to do that, but until now they didn't make anything regarding to this part. Here on this nozzle, actually it should be with an elbow. Okay, the bottom nozzle on the hedge. Actually, it may need an elbow, which will be exit from the skirt. As mentioned on the access database file, no information about this elbow, so SEG will detect it as a radial user without elbow, connected to a flange directly. Ratchet, I hope that you are recording this session to send the download link for.
Yes, Ahmed, it has been recorded.
Yes, okay, okay. As you can figure, the skirt will be created from 2 pieces, as we discussed. So on the access database file, it should be 1 skirt only, and make the total length of the skirt with the accumulated lengths. And you can control each blade thickness. If we take a look to the skirt itself, here you will find the ability to control the thickness of each course. So you can define the thickness here, change the thickness for the second course, or to add 2 new courses, add a bracing beam and a tailing lug if you would like to add a tailing lug, add a sleeve vibe. So you have many options to this skirt. If you take a look to the image on the right hand side, you can add tailing lug, add bracing beam, so you can control over from this way, which is not included on BBL, by the way. So the creation of this equipment based on the number of elements it may take. So let's make a refresh for the tree, figure out where we are stand. Now we are generating N3, so it may take between 4 or 5 minutes to generate the other elements. So let's wait until finishing the complete model. By the way, any questions during the generation of the equipment?
One more question was regarding this RF pads. Can we get the flat pattern or the development of the RF pad?
Cool. So I will tell you how we can do that, inshallah, after finishing this. We will
Okay.
make a nozzle opening on the shell course and get a flat pattern. By
Okay.
manual way, if you would like to get it, or by using the tool on SEG, because SEG is the tool to create metal flat pattern to give you the ability to get all sheet plates in your model and export it in DXF extension or DWG extension, scale 1 to
Okay.
1.
Okay. And more of for the RF pad, will be more interested to see the RF pad on dish end basically, rather than on the shell. Yeah, shell also you can show, but more of
What do
on
you
the dish.
mean by RF band? What do you mean?
Reinforcement pad.
Yes, the
So
development of the enforcement. Is that right?
Yes, yes, but
Yes. Okay.
more.
Okay. As mentioned, SEG will detect all sheet plates on the model and create a shell development for it.
Okay.
Okay. Or you
Okay.
asking for another point?
No, no, no. It is the same.
Okay. Now we have 4 nozzles complete.
आणि हे नोजल
Ahmed, meanwhile, this file is opening. So
Yeah.
would also request you to you have saved this database file, right? After modifying this by
Yes.
changing the units. and also the name. So I would request you to send that file back to us so that we can try it at our end also.
Okay. So from here, okay. So as we mentioned, after importing, you should save the all three nodes. After importing the nodes, you will select the bezel and click on resave to save all information here on the tree.
Okay.
Before sending elements to those inventory. Okay, now we have the complete model of the equipment, and you can make the fabrication requirements on it, like adding here on the skirt, we could add the skirt event, skirt access, skirt opening. For this source nozzle, we could add an elbow for them. But right now, let's make a nozzle opening on this shell blade, for example. Let's make an opening for those nozzles. Okay, so let's check the second course. Here on this course, we have N3, N10B, and N11. So from the assembly tab, we will click on opening and load all nozzles here. And let's select the nozzle on the course 2. So let's remove all nozzles and keep nozzles on course 2 only to make an opening for those nozzles only. So we will create an opening for those 3 nozzles, and you can control the clearance. So let's make the clearance as for all nozzles. Sorry. Let's remove them again and select the nozzles on the shell course like that, and click save setting. And now let's click extrude process to start creating the holing of those nozzles on shell. So automatically SEG will create opening on shell plate for those nozzles. And by the way, sometimes you may not need that because some companies don't ask for the cutting or sheet metal flat pattern, but some other companies ask for that. Here you can figure that SEG create the nozzle holing, and in this case we can get the sheet metal flat pattern for this element. If you would like to create it separately by hand like that, you can open this element and click create flat pattern to get the nozzle opening like that, and you can export it by that way to create drawing view or open drawing, or you can export it in another extension, which is DWG or DXF extension. You can create drawing view, or you can use flat pattern tool. Yes,
Ahmed, can you go back to the flat pattern, the development?
Yes.
Can you zoom into the openings?
Yes. If you would like to, it will be clear if we have an oval opening with a large diameter. So let's add with a hillside nozzle. Let's add a nozzle on the first shell course. So let's select this shell course and add a nozzle like NAS, for example. This nozzle, we will make it, let's say it's a nozzle from blade. So the shell diameter, let's measure the shell diameter. What was the shell diameter? Okay, that's the radius, so it's 3 meters. So let's make this nozzle from, let's say, like that, and let's make it hillside with offset, let's say 40 millimeters, and let's add like that, 3 millimeters thickness. Okay, and let's increase the projection. Let's run this. Okay, so let's increase the offset value a little bit. So if we take a look right here, so let's make it 700. Click start to increase the offset a little bit. Okay, now let's create the nozzle opening for, so it's laid on a welding line, so we can make it on the other side, so let's make it counterclockwise. Yes.
Hello? Ahmed,
Yes.
can we, because I think what you're trying to do is you're trying to create the openings and also the reinforcement pad, right? So can
Yes,
we,
I'm making an oval opening. Make a hillside nozzle to give you,
oh,
because the small nozzles will give you the indications that you would like to see. Here I will load all nozzles, and from here I will select only the nozzle ANS. And let's
and once you're done with this also, what you can do is you can try with the one nozzle which is on the dish end, right? Which is very close to the knuckle. So you can
yes,
try to,
but the dashed head,
try.
you cannot get a flat pattern for it. It's a formed head,
Okay.
rolled on 3 dimensions, not in 2 dimensions, like cone or shell. Cone or shell, you will use a roll way to make the rolling for it, but the heads are formed on 3 directions, not in, you get my point. Hello.
Yes, sir. Yes, yes, yes.
Okay, but I will show you an option in Autodesk Inventor will give you an estimated dimensions for the main blade, which you can use it before forming. Okay, now we have this shell. We open it. Let's open this shell course, and if we try to get a flat pattern for it, you can figure that this oval opening now it's here as an oval. It's not a circle. Okay, the same for weir blade. Okay, is that okay right now for the shell opening? For the weir plate, let's open the shell blade itself, because we make this nozzle from plate. If you would like to get the flat better, you can figure that that's the configuration of the nozzle plate that you would like to cut. And for the weir plate, let's see it, the flat better. That's the oval flat pattern of the nozzle. By the way, in SEG, you will find a tool. This tool is create flat pattern. If you open it, it will automatically search for scan part. It will make a scan for all blades on your model, and after making a scan, you can select the required items and make exporting for it to DWG or DXF. So let's wait for the scanning.
So, Ahmed, once we are done with this flat pattern, we would like to share our screen because we have opened the same file which you had shared to us. Okay. Hello, Ahmed.
Should stop my screen.
Yes, yes, please.
Ahmed,
Stop sharing this.
Stop.
Ahmed.
So what we have done is we have opened the same file that you shared us, the MDB file, and this is the result what we see. Section view mother नाम section view mother.
I think you didn't follow the steps that we because I did it live after sending it.
We just open the list.
No, what we have done is we have just imported this file.
Yes, but you should save the elements after importing.
Okay, so
Did you make a section? Kindly
uh,
remove the section. Kindly remove the section. Click on
just a minute.
Thank you.
Okay, so can you see now? Side view here. There's a reference to my
Yes, as mentioned, you didn't follow the steps. You didn't make a save SEG key before completing this.
Okay, so can we do one thing? Can we try to reopen and can we just guide through the initial procedure?
Okay,
So that
kindly open SEG.
Okay.
Okay.
SEG open kar. SEG. Okay, so you can
And
tell us now.
from the setting tab, open the edit tab.
Setting tab. Yes.
Edit, not setting. Edit.
Edit add settings. App settings.
No. Edit tab.
Edit tab. Where is it?
Wherever the settings से बात
Yes, and click on restore inventor model, which is the green button. Restore inventor model. No, not that one. The green. Yes, that one. Yes, and click on
Yes.
press yes to start data. Okay. Part scanning complete. Okay, so select the project itself, which is the vertical BD. Select
Which one?
Project node on the SEG tree, which is vertical BV. The node on the tree.
सगळ्यात वरचा. Top of the tree. The vertical PV, right?
The project, not the vessel.
बरोबर. Okay, so
Select
next.
it again. Click on it on the icon itself. Again, please.
Click on the icon.
Yes, right click now on it.
Right click. Right click.
Create a vessel. Create vessel, the first choice. Create vessel.
Result.
First choice, create vessel.
Create vessel. Create
First
vessel.
choice on the list. First choice.
Okay.
Yes. Write any name here. 1, 2, 3. Any name. 1, 2, 3.
Name देना बेहतर. Test. Okay.
Yes, and click add. Now delete the first vessel. Go to the top of the list and select TBA vessel. Right click and delete. The vessel, not the project.
Vessel.
Select TBA vessel, please.
TBA. They delete. TBA. That. This one, right?
Delete it. Yes, delete it.
Delete. Test.
Yes, now we have an empty vessel.
Correct.
Okay, now right click and select import. Access file. Okay, access. Select the file that I send it to you. Yes. Open. Save.
Save.
Okay, now select the vessel which is named test. Select.
Right click कर देना vessel ला सगळ्यात वरती
And okay, select the vessel as a vessel.
So shall we create vessel again?
No. Just select the vessel. Select the vessel. The
Test.
vessel, not the project. The vessel.
Test. Okay.
Yes.
Now.
And from File tab, open the File tab. Yes, and click Resave. Now click Yes. Now come back to SEG, please. Minimize the Autodesk Inventor.
Minimize.
Yes. Okay, we will wait until saving this. Okay. Hello? Hello?
Yes, Ahmed.
Would you mind
Next.
to increase the window of Autodesk Inventor and minimize it again? Open and minimize. I would like to check.
Open आणि minimize कर. Open कर inventor minimize. परत कर. Is it okay
now?
now?
The saving is done. Now the saving is done. Kindly select the skirt.
We need to select the test again, right? This one?
Okay, you can run the model now from the assembly tab.
Elements मध्ये.
Select assembly tab and no. Assembly and run the model. Assembly tab.
And start.
Start, yes.
Okay.
Now you can open Autodesk Inventor and figure out how.
आता वेगळं काय करायचं काहीच नाही.
Did you follow those steps during importing on the first time?
Yes, we did the same thing. I'm not sure what went wrong there.
Okay, so let's check it.
Okay.
आणि internal तुमचं काय?
So Ahmed, I think we are good on this model. Not sure what we missed out, but at least we can find it in the recording later on.
Heat exchange.
Hello, Ahmed. Are you there?
Sorry. I wanted to drink some water. Yes.
Okay, no issue.
Okay.
So I
Now,
think we
if you, I would like to adjust some options here from the tools, open tools.
tools
Okay,
in
no problem. Okay,
Inventor or
now you
SEG?
can figure that if you follow the steps in the correct way and understand it in a good way, you will not get any errors during your working. Yes, that's fine.
Okay, but at least for now, I think it seems that it has been opened correctly. So anyway, my next question was regarding the heat exchanger. Can we import the heat exchanger files from PVLit as of now and get that into the SEG?
Yeah. You should know that the Access database file not include any information about the heat exchanger. So no
Okay,
way
so
to read, so no information to read it right now. We
okay.
told to Hexagon BDM many times to export some information regarding tube pattern and tube sheet, but they promised us to do it, but until now they didn't.
Okay, so as of now, it is not possible, right? I mean, just for our information.
Or pressure vessels and towers.
Okay.
Okay, but by the way, on the training course, I think we will deal with those things and how you can control on the options of Autodesk Inventor. Hello?
Yes, Ahmed, we didn't get you. Can you come again?
Because someone exit from the meeting.
Okay. No, it's open still.
Okay. Now let's come back again to the model. Here we make a scanning for that, so you can select the required items that you would like to make a flat pattern for it. And from here, let's select the DWG extension. Okay, and let's export the sheet metal for those. And from here, let's go to the desktop and select the demo of this one, DV2. Now SE will export the sheet metal form pattern for those plates in DWG extension. So let's open that one. Here we have those shell results. Okay. Now we have those. So if we open them here, sorry. Okay. Now that's the shell blade. Okay, so you can
Ahmed, just a small question here. Like even on the cylinder or the shell, if we have any openings, those will not be perfectly a circle, right? But it seems that here those are almost like a circle here.
yes, but they are not a circle. If you select them like this, you can figure that it's not a circle.
No,
Because
what
it's
I mean,
not a circle.
what I mean to say is they should be something like a ellipse. Basically, when we actually ellipse
Spline,
or oval.
spline, closed spline looks like an ellipse. It's not an ellipse.
No. What I'm trying to say here is not about the entity type in AutoCAD. The shape basically. Whenever the opening is on a cylinder and you flat it out, it should not be. Yes, in this case we see that it is like a oval, right? Not a perfect oval, but because it is on the side or it is tangential nozzle. But uh, whenever it is a radial nozzle, in that case also it should be like a oval, right?
Like an oval, but not oval. Like. You know what I mean? Like an oval. If you measure this length from the highest point to midpoint, you will find it differ from the width. Okay.
Okay,
So
okay.
it's an oval, but it's you get my point?
Yes, yes, got it.
Okay.
Maybe
That's the second shell. That's the second shell, and that's the nozzle blade, and you can figure that the thickness, chamfer or thickness, the rebad of the nozzles, inside nozzles that we generate, and that line is the bending line. Okay, those lines are the bending lines. And you can control the color of this line. You can make it hidden or center line. So during exporting, you can control it. Okay, any other questions?
No, Ahmed, I think we are good on this, and thank you for your time and lovely demonstration of this application. And most of the doubts are clear. So we will explore more on the same, so that we'll don't bother to trouble you again if we are stuck in somewhere.
No problem. Anytime you can contact us.
Yes, yes. So, and it would be great if at all this meeting is been recorded, so you can just share the same, so that we can follow the steps what you have shown also, right?
Inshallah.
Yes,
But
yes, it's
the,
important.
the versions that you have, not include the tube sheet that we modify.
Yeah,
Okay,
yeah.
it will be released on the next release, inshallah.
Okay, so you mean to say is that the development part what you have done that has not been make generalized as of now, so that you have just
For the flanges and liner for body flange and the tube sheet, the stud outlet with user-defined dimensions, those will not be in your version because we just our development team modified
Okay,
this.
okay, okay. So that has not been released yet to the customers, I would say, right?
Yes, that's it.
Okay, so no problem, no problem. At least you have demonstrated that it is possible, and thank you from our side that with a very small period of time, within a small period of time, you have made it happen. That's really commendable. Thank you so very much for the same.
Alhamdulillah, alhamdulillah. And thank you for your valuable time. And I hope this session can cover most of your questions. And if
Yes,
you have any more, kindly feel free to contact us.
yes, Ahmed. Yes, yes. Thank you once more.
Thank you very much. Thank you very much.
Yeah,
Okay,
Have a
thank
thank you
you.
nice
very
day.
much, Ahmed.
Have
Thank
a
you
nice
very
day.
much for your time, Ahmed and Sachin, sir. Thank you.
You're
Yeah,
welcome.
yeah.
Have a nice
Thank
day.
you.
Salam alaikum.
Okay.
Okay, bye.